All right, so today we're going to start looking at an aspect of a useful application of stoichiometry, I should say. We're going to be looking at something called limiting agents or reagents. So let's look at my favorite easy equation, H2, 2H2 plus O2 becomes 2H2O. So the first question is it balanced? So over here it looks like I have 4 hydrogens, 2 oxygens, 2 times 1, 2 oxygens. So we're good there. So let's say that I'm working on I'm designing a space station. How about that? And I need to figure out a way to make water using hydrogen and oxygen gas. Let's say we come up with some imaginary simulation that we have 10 grams of hydrogen and 10 grams of oxygen. I want to know, out of these two, which one is going to limit this reaction. Essentially, which of them will create the least amount of water is really what it's going to come down to. So to figure out of this one, if I have 10 grams of H2 and 10 grams of O2, which one's my limiting reagent? I'm essentially just going to do a stoichiometry problem twice. I'm going to aim them both for one of my products. So in this case, I only have one product, and that's H2O. So to start off with, let's get it set up. So I have 10 grams. Oh, that was weird. 10 grams of H2. Get that set up right away. So starting off with, I'm trying to get them both to either mass or moles of H2O. Let's go mass. That way I know exactly how much water I'll be making. All right. So the first conversion, according to the shortcuts on our sheet, is we're going to take our 10 grams times 1 mole of H2, which has a mass of 2 grams. One hydrogen has a mass of 1 gram. 2 hydrogens have a mass of 2 grams. Okay, so that's the first conversion. Second conversion we're going to look at will be moles of Y, so the moles of water from here, so it looks like it's 2. And then over the moles of X from the chemical equation, so if I'm looking at H2, I'm looking at 2 as well. All right, and the last conversion I need to do is take this times 1 mole of H2O over the molar mass of water. 2 hydrogens is still 2. 1 oxygen is 16. 16 plus 2 is 18. All right, so it looks like I've got grams of hydrogen, moles of H2O, moles of H2O, moles of water, moles of water. All right, so I'm ending with grams of H2O. So now for the math, I've got, open up my calculator. So it looks like I'm going to take 10 divided by 2, because it's on the bottom. 2 over 2, those cancel, and so 10 divided by 2 times 18, because it's up top. And the answer I get is 90. 90 grams of H2O. That's if I started with 10 grams of H2. Now let's do it again. This time I'm starting with 10 grams of O2. So essentially the first one, once again, is 1 mole, what I'm starting with, in this case O2. All over the molar mass of O2, so I know oxygen, 1 oxygen is 16, 2 oxygens is 32. Now I need to go from moles of oxygen to moles of H2O. So up here, moles of H2O from the equation goes on top, so that's 2 moles. And that's over the moles of oxygen from it, which looks like 1. And this step I'm going to pull right from that last one, so the mass of the water, molar mass of water, 18 over 1 mole. water. So in this case, double check my unit analysis, grams of O2, grams of O2, so those cancel. Moles of O2, moles of O2, those cancel. Moles of H2O, moles of H2O. So now I'm left with grams of H2O again, grams of water. So in this case, the math I'm going to do is 10 times 1 over 32, or divided by 32, times 2 times 18. This time I get 11.25. That'll be grams of H2O. All right, so now looking at these numbers, so if I have 10 grams of hydrogen, I can produce 90 grams of water. That's assuming I have enough oxygen. Or if I only have 10 grams of oxygen, I can only produce 11.25 grams of water, H2O. So in this case, if I have 10 grams of each, the one that's going to limit the reaction is the 10 grams of O2. And then if I'm also asked, well, using that limiting reagent, how much water can I produce? Looking at these two, 11.25 is way less than 90. So starting with these two amounts of hydrogen and oxygen, the oxygen is definitely limiting it because I'm only able to make that 11.25. All right. That really is the most useful aspect of stoichiometry, is trying to figure out, given certain amounts of reactants, what's the most amount of product you can make? This is one of the big things chemical engineers do. Biologists are going to use this as well for kind of determining metabolic pathways, stuff like that. The black background, the white lettering, drawing, writing, I'm hoping that works out, so give me some feedback about that in class. Other than that, that should do it for today.